So our first example is we've got a large bag that holds marbles of the following colors. Those colors are blue, green, orange, and pink. And we have another small bag that holds marbles that are red, green, yellow, and orange. So we've got two sizes of bags. So I'm going to start with our two subsets because I think we can take our subsets and then make sure that we have everybody when we go back. So for our large bag of marbles, our colors are blue, green, orange, and pink. And our small bag of marbles consists of red, green, yellow, and orange. So we've got our large bag of marbles and our small bag of marbles. In our universal set, all of the possible colors of marbles are present. So we need to include blue. Yep, blue's in one, just a large bag. Green, which happens to be in both. Orange, also in both. Pink is only large. And then we look to our small ones. So red, do we have red yet? Nope, we'll add that to our universal set. Green is already included. We do not have yellow, and we do have orange. So that will conclude our universal set. So we're going to go ahead and we're going to make our first Venn diagram. You guys have already used Venn diagrams. Your wonderful English teachers have showed them to you. So we're going to go ahead and bring them on over to math. That is an awful rectangle. My apologies. Okay, so this, the whole box, would be our universal set. So if something wasn't included in either one of our subsets, it would kind of just be floating out in the ether. So and then we're going to draw two circles with a little bit of overlap. So I've got my large circle and I've got my small circle. So on the left is going to be our large bag of marbles, and on the right is going to be our small bag of marbles. So in our large, we've got blue, green, orange, and pink. And in our small bag, we've got red, green, yellow, and orange. So what happens though with our Venn diagram is we've got a couple of colors that are in both. So we've got orange in both. So instead of writing them twice, we're going to go ahead and write them in the middle in our overlap, a term that's in both. And then there's one more color, and I don't want to go all Dora the Explorer on you, so we just know that that color is green. So we should have the same number of colors in our universal set as in our Venn diagram with our two subsets. So do we have blue? Check. Green, it's overlapping, check. Orange, overlapping, check. Pink, check in the large. Red, check in the small. And yellow, check in the small. So we're going to go ahead and we're going to find the intersection, our overlap, that's in large and in small. And we're going to find our union. So we want to know L and S. Who is in both? Well, we got green and orange. And then we also want to know our union. Who is in large or in small? So this one's going to look a lot like our universal set did up top. So B, P, G, O, R, Y. So for those of you wondering, what if I had a random color? Let's say there was a random purple marble just floating out in the ether, but it wasn't in the large bag or the small bag, so it'd be okay. It'd be out here it'd be out here on the side, and it would be purple, but it wouldn't be in our intersection or our union because it isn't included in the subsets. Some examples later on, we'll get into that. Example number 2. Suppose a universal set consists of all single-digit, whole, positive numbers. 2 subsets are created from the universal set, the set of even numbers, and the set of all multiples of 3. We're going to define our universal set, our 2 subsets, draw a Venn diagram to represent each of these sets, find who is not in E, who is in the intersection of E, and then find out who's not in E or in M. So first off, we're going to universal set. So it says all numbers that are single digit, whole, and positive. So we're going to start with 0. They may not be in 0. So you know what? Let's not put 0 in there. Let's just start with 1. So our universal set is going to go with 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, those are single digit, whole, positive numbers. And then we have 2 subsets. We've got all even numbers, that's one subset, and we're going to label it E. And then all multiples of 3, subset M. So all even numbers in our universal set, we've got 2, 4, 6, and 8. Those are both even and positive and single digit. And then multiples of 3, meaning those numbers who are divisible by 3, 3, 6, and 9. So we've got our 2 subsets. We defined our own subsets outside of our universal set. So we're going to go ahead and draw a Venn diagram. So remember, we got 2 circles because we have 2 subsets. If we had 3 subsets, we'd have 3 circles. I don't understand why I keep making one very large and the other one not very large, but we're just going to go wonky with that one. So our universal set, and then we have our even numbers, our multiples of 3, and then we'll see this time we're going to have some weirdos just lying around, not in any of our subsets, but are in the universal set. So for even, we got 2, 4, 6, 8, multiples of 3, 3, 6, 9. Now, is there a number that occurs in both? And for those of you playing at home, there absolutely is, and is the number 6. So it goes on to the intersection, the overlap. So our first example, it tells me who is not in set E. Wait, coach, you forgot. What are the weirdos that are laying around? Who doesn't have a group but is in the universal set? Well, those are 1, 5, and 7. Single digit positive numbers that are not even or multiples of 3. So we want to know who is not in subset E. So basically what we're going to do is we can shade, I know this is going to be tough, so I'm going to take a highlighter here, and we're going to shade what's not E. So that would be anybody in M and anybody who is outside of it. So we can't include 6 because he is present in E, and 2, 4, and 8 are also there. So a subset who is not in E, remember a complement means not, that little prime right there, So E's complement, who is not in there, 1, 3, 5, 7, and 9. We see an intersection. Intersection means and. Great answer. So we got who is in E and in M. Well, intersection of E and M, there's only one, and it's 6. And as you can see, they can really start to mess with us. Remember, bar is not, and this little U means or. So who is not in E or in M? So we've got two options here. We got to figure out who is not in E or in M. And so that means who is basically not in either subset. And that's our weirdos that are hanging out. So E or M bar, we got 1, 5, and 7. Alrighty guys, that completes page 2.